Hi, welcome to Lesson 5, Session 2. Today we're going to be continuing our work with dividing, and we are going to be learning today how to estimate quotients. So today we won't be finding, for the most part, we will not be finding exact answers. We will be trying to find answers that are estimates that are going to get us as close to the answer as possible, but will give us a really good idea of what our answer will be using a little bit easier numbers. So we're going to be working in our Ready Math workbook on pages 81 through page 84. So go ahead and take out your Ready Math book and turn your book to page 81. Now, as always, we're going to go ahead and answer our 3 questions about our the problem that we've been given. So the problem is, a toy company packs 504 robots into 21 boxes. Each box has the same number of robots. Show how you could estimate the number of robots in each box. So the first thing we need to do is we need to say, all right, what is this problem talking about? So this problem is talking about robots and boxes. Okay? And then what are we trying to find out? We're trying to find out, and we're trying to estimate the number of robots in one box. And then we need to know what is our important information. There's 504 robots in 21 boxes. And then I'm also going to say that what we also need to mark as being important information is that we are going to estimate. We're not trying to find an exact answer. We're trying to get an answer that is close to how many robots would be in 21 boxes. So what I'd like you to do right now, I'm going to read this one more time, and then I want you to pause your video and try and solve it. There's no right way. I could probably solve it like 4 or 5 different ways. So I want you to come up with the way that is your best method. And the problem says, a toy company packs 504 robots into 21 boxes. Each box has the same number of robots. Show how you could estimate the number of robots in each box. So go ahead and pause your video and go ahead and solve this using your best method. Okay, if this were me, I would start out by taking my 504 and my 21 and finding my best estimate for what for a number that is close to both of those values. So I know that 504 is very close to 500. So I'm going to say that there are about 500 robots. Okay? And then I know that 20 is close to 21. So I'm going to say that there are about 500 robots and there are about 20 boxes. And so then I want to go, okay, well, how many robots can go into each box? And so then I can use a multiplication sentence and I can say, well, I know that 20 times 10 is equal to 200. And that's kind of far off from 500, so I'm going to keep going. I know that 20 times 20 is equal to 400. Now we're getting close. All right, let's see. I know that 20 times 30 is equal to 600. Oh no, I went over. Okay, well, let's keep this 20 times 20 is 400. Now, I also happen to know that 20 times 5 equals 100. So if I use those two values, I can take the 20 here and the 5 here, and I can say, I know that 20 times 25 equals 20 times 20 is 400, 20 times 5 is 100. So 20 times 25 would be 500. So there are about 25 robots in each box. Did you come up with about 25 robots? Don't worry if you didn't, it's totally okay. That's my estimate, and your estimate may have been right if you'd used different numbers than I did. This is just one way to solve the problem. There are other ways you could have solved it. Go ahead and turn the page to page 82. So we're going to go ahead and look over at this problem, or this page 82. We're going to explore different ways to understand how to estimate. Remember, we're not finding exact answers today. We're estimating quotients when dividing whole numbers. We're going to use the same problem that we used before. The toy company had 504 robots packed into 21 boxes. Each box had the same number of robots. Show how you could estimate the number of robots in each box. So the first method you could do, which is the method that I use kind of a combination of the two, but is compatible numbers. You can use compatible numbers to estimate a quotient. Compatible numbers are close to the value of the actual dividend and divisor that allow you to multiply or divide using basic facts. 520 are compatible numbers that are close to 504 and 21. That's similar to what I did on the other page. You can use them to estimate by thinking 500 divided by 20 means 20 times what equals 500. We know, because we just did it, that 20 times 25 equals 500, because we just solved that on the last page. You can also use the inverse relationship. That means the opposite. In other words, if you're dividing, you can change it to multiplication or multiplication to division. You can use the inverse or opposite relationship between multiplication and division to estimate a quotient. So 504 divided by 21, or 21 times what equals 504? So 21 times 10 is 210. 21 times 20 is 420. 21 times 30 is 630. So in this method, we would know the answer is between which two number of robots per boxes. Well, 504 goes between 420 and 630. It's in here somewhere, 504. So we would know that our answer would be somewhere between 20 and 30 robots, because 504 goes between 420 and 630. We know our quotient will also be between 20 and 30. All right, let's make some connections between the two methods we used. Look at the first modelet. Why are 520 good choices to use for compatible numbers? Why not round to the nearest thousand and use 1020 as compatible numbers? Go ahead and write your answer and pause and then unpause when you have your answer written. All right, I know that we want to choose numbers that are close to the dividend and the divisor to get an estimate that's going to be close to the actual quotient. If we used 1020, our answer would have been way too high, because 1000 is very far away from 504. But 500 is extremely close to 504. Number 2 says, how can you find the quotient 500 divided by 20? What estimate does this give for the number of robots in each box? I talked about that when we worked on the last page, because I knew that 20 times 10 it was 200, 20 times 20 was 400. I also knew that 20 times 5 was 100. So 20 plus 5 equals 25. For number 3, look at the second modelet. So now we're just talking up here about the compatible numbers. Now we're talking about using the inverse relationship and the multiples of 10 chart. How can you look at the second modelet? Why do you multiply 21 times multiples of 10? Could you multiply 21 by multiples of 5 instead of multiples of 10? What do you think? Go ahead and pause your video and write your answer. All right. I think that multiplying by multiples of 10 is so much easier than multiplying by multiples of 5. With multiples of 10, you could almost do it in your head for the most part. But when you're working with multiples of 5, you would have to really do some math to try and figure out all of those multiples. So that's why we use the multiples of 10, simply because it's easier. Now we're going to look at this table. Between which two numbers is a good estimate for the number of robots packed in each box? We actually already answered that question down here. We said that 504 is between 420 and 630. So we know that there are between 20 and 30 robots per box. So now, what do the methods of estimating quotients in the modelets have in common? What does the compatible numbers and the inverse relationship with the multiples of 10 chart have in common? Both methods use easier numbers to help you estimate. It's that simple. What's nice about both of these is while I don't know in my head what 504 divided by 21 is, I can do what is 500 divided by 20 in my head. So therefore, we're just taking numbers that are a little bit easier to work with and doing the math that way. So now, I want you to look back at everything we've learned today. Look at your try it strategies and your model it. So look back at the method you tried here, and then look at both of these methods. Which models or strategies do you like best for estimating quotients? I also put here that we use compatible numbers and we use multiples of 10 chart. So if you don't remember what strategy you like best, here are two of the strategies that you could fill in the blank. And then I want you to tell me why. So go ahead and pause the video and tell me what strategy is the one that you like using best. All right, go ahead and turn the page to page 84. We are going to practice estimating the quotient. So on number 7, we are going to estimate the quotient 342 divided by 38. This one has some compatible numbers that are very close that will make this pretty easy on us. So I know that 342 is very close to 350. And then when I look at 38, guess what? 38 is very close to 35. So if I divided 350 divided by 35, this one's pretty easy because it's a multiple of 10. And so I know that 35 goes into 350 10 times. So the estimate is about 10. So if I were figuring out what 342 divided by 38 is, I know my answer is going to be somewhere around or about 10. Now we're going to do number 8. This time I'm going to show you how you could make your own multiples of 10 chart. I also will have these available. These are your multiples of 10 chart that you can print out and put into like a plastic sheet protector and then write on it with a whiteboard. But if you don't have one of these, you can make it yourself. It's not that hard to make it yourself. So for number 8, I'm going to go ahead and make it. So I've got, you just draw a big long rectangle. And then you make one small, and then you just make a few boxes. You don't usually need too many. Sometimes you're going to go all the way over to 100, but today I don't think we're going to get quite that high. So, and then here is your x, because your x is going to be what your divisor is, what you're dividing by. So you're going to put 23 here. And then in each of these smaller boxes, you're going to put your multiples of 10. 20, 30, 40, 50. Okay. Now, we're trying to figure out what is 1,103 divided by 23. So what we're going to do, here we used the compatible numbers. Down here, we're going to use the inverse operation. We're going to figure out, well, 23 times what number gets us really close to 1,103. So 23 times 10 is 230. 23 times 20, I don't know that right off my head. But guess what? The way that this works is you're just going to add 230 every time you move over. So 230 plus 230 is 460. And then I don't know what 23 times 30 is, but 460 plus 230, if you want, you could even write it down below so you could do the math, equals 690. 690 plus 230 is 920. 920 plus 230 is 1,000. Oops. Forgot a 1. 1,150. Now, if I was in my class would say, stop, Mrs. McGuire, because we have passed our dividend. So, we know that our dividend is between 920 and 1,150. So now, if we're looking at the equation, 1,103 divided by 23, we know that that falls somewhere in here. So that means our answer is going to be somewhere between these two values. So we could say our answer is going to be between 40 and 50. Finally, we're going to work on number 9. It says, Camille arranged 238 chairs into equal rows of 14 chairs. Which of the following is the best estimate for the number of rows she made? A number close to 30, about 20, a number between 30 and 40, about 10. I'm going to go ahead and make another multiples of 10 chart because that is just my favorite method. I think that making these is the best skill you can learn because it helps you. If you don't know your multiplication facts, you can easily make this on your own without even having a multiplication chart. So if we're trying to get up to 238 and we have rows of 14. So 14 is going to be our divisor. So 14 times 10 is 140. 14 times 20 is 280. 14 times, oh, do I hear you yelling stop? You should be because I've gone over my dividend. My dividend is 238 and that falls somewhere in between 140 and 280. So I know that my answer is going to be somewhere between 10 and 20, because 238 is between 140 and 280. So what letters can we eliminate because they could not possibly be right? That's right. We could definitely eliminate choice C because it says it would be a number between 30 and 40, and we know that that's not the truth. We could also eliminate choice A because we know it's not close to 30 because it's somewhere between 10 and 20. So now we have to decide, is the answer about 20 or about 10? This is where you have to do a little bit of thinking. So if you had a number line and you had 140 here and you had 280 here, where would 238 be on this number line? Well, I would say halfway, it would be about 210 would be about halfway. And so 240 or 238 is close to 240, and so that's going to be somewhere about right here. So if you're looking at this number line, is 238 closer to 280 or is it closer to 140? That's right, it's closer to 280. So if it's closer to 280, that means it's closer to 20. So our answer is B, about 20. You're going to go ahead and keep practicing. Remember to make your multiples of 10 chart. It will really help you out, and once you figure out how to do it, you'll be using it through the rest of our division lessons. So please practice using that method during your independent practice today.